and it continues to captivate astronomers today. So what causes this spectacular outburst of energy? The mechanism isn't a single process, but a family of related events, all revolving around a very peculiar kind of star. The main culprit in most novae is a white dwarf. This is the incredibly dense, hot remnant of a star like our Sun after it has exhausted its nuclear fuel. Think of it as a stellar corpse, a compact ball of matter about the size of the Earth, but with the mass of the Sun. A single teaspoon of white dwarf material would weigh several tons. These objects are usually quiet, fading slowly over billions of years. But if a white dwarf is not alone, if it has a companion star, then the stage is set for a truly cosmic drama. The key to a nova lies in this binary relationship. If the white dwarf is close enough to its partner, typically a main sequence star like our Sun or a red giant, its immense gravity begins to pull material away from the companion. A stream of gas, mostly hydrogen, is siphoned from the larger star and spirals down towards the white dwarf. This material doesn't fall directly onto the surface. Instead, it forms a swirling hot structure around the white dwarf called an accretion disk. As more and more hydrogen accumulates on the white dwarf's surface, the pressure and temperature build to unimaginable levels, setting the scene for a truly enormous explosion. The most common type of these explosions is what we call a classical nova. As the stolen hydrogen piles up on the white dwarf's surface, it becomes hotter and denser. The gravity of the white dwarf is immense, compressing this layer of fresh fuel. When the temperature at the bottom of this layer reaches about 10 million degrees Celsius, something extraordinary happens. A runaway chain reaction of thermonuclear fusion ignites, the very same process that powers living stars. But this isn't the controlled, stable fusion found in the core of our Sun. This is an uncontrolled, instantaneous detonation that blasts across the entire surface of the white dwarf in a matter of seconds. This explosion is what we see as the nova. It hurls the accumulated layer of gas out into space at speeds of thousands of kilometers per second, creating an expanding shell of glowing debris. The energy released is enormous, causing that sudden dramatic brightening that can make the star visible to the naked eye. What's remarkable is that the white dwarf itself usually survives this cataclysm. The explosion is a surface event. The star underneath remains intact. Once the fireworks are over, the process can begin all over again. The white dwarf, still orbiting its companion, once more starts pulling hydrogen onto its surface, setting the stage for another explosion far in the future.